Niacin's contribution to brain function is both profound and underestimated. It is increasingly clear that this unassuming B vitamin plays a central role not only in supporting general cognition but also in protecting the brain against long-term neurodegenerative changes. The connection lies in the way niacin sustains the brain's energy metabolism, combats oxidative stress, and facilitates the repair and maintenance of neural structures through its essential role in NAD, nicotinamide adenine dinucleotide, production. NAD is not just a metabolic intermediary. It acts as a coenzyme for a host of enzymes that are directly responsible for brain health, including sirtuins, which regulate inflammation, DNA repair, and cellular resilience. The brain, being one of the most energy-demanding organs in the body, requires a constant and efficient flow of metabolic energy to maintain everything from memory and mood regulation to attention and executive function. This demand makes it extremely sensitive to any disruption in cellular energy supply. NAD is at the heart of this system. When NAD levels fall, whether due to dietary niacin deficiency, chronic stress, aging, or other metabolic disruptions, neurons begin to suffer. Mitochondrial efficiency declines, oxidative stress builds up, and the ability to repair DNA damage is compromised. Over time, this can translate into the very symptoms we associate with aging: brain fog, forgetfulness, mental fatigue, and slower processing speed. However, the reality is that many of these symptoms are not inevitable consequences of aging, but rather reflections of suboptimal cellular support, in particular, inadequate levels of NAD or its precursors like niacin. This subtle but impactful micronutrient imbalance is easy to miss. Most people experiencing mild cognitive decline don't think to consider their B vitamin status. Instead, they attribute it to stress, overwork, or just getting older, when in fact, the brain may be quietly starved of the nutrients it needs to maintain sharp function. Studies have begun to show that boosting NAD levels through niacin or related compounds like nicotinamide riboside may improve markers of brain health, including increased mitochondrial function, better resistance to inflammation, and even improved cognitive performance in some populations. Animal models have demonstrated that NAD supplementation can slow the progression of diseases like Alzheimer's, and human trials are starting to explore these effects more deeply. Although definitive conclusions are still in progress, the biological plausibility is strong, particularly since NAD-related pathways influence not just energy, but neuroplasticity, synaptic signaling, and even the production of critical neurotransmitters. Furthermore, niacin may act as a buffer against the neurological damage caused by chronic inflammation. Sirtuins, the NAD-dependent enzymes, help regulate inflammatory responses by modifying gene expression and stabilizing mitochondrial function. This is crucial in the aging brain, where chronic low-grade inflammation, inflammaging, is a common driver of cognitive decline. By sustaining NAD levels, niacin indirectly helps to suppress harmful inflammatory signaling and preserve the integrity of neural circuits. It's also worth noting that the symptoms of niacin deficiency, even at low levels that don't reach the clinical threshold for pellagra, include irritability, poor concentration, anxiety, and fatigue. These are subtle signs, but they are extremely common and often dismissed as lifestyle-related or psychological in origin. In truth, the line between clinical deficiency and suboptimal function is not as sharp as traditional nutrition might suggest. Many people are living with marginal niacin status that is enough to impair peak brain function without triggering overt disease. Given its wide-reaching benefits, from maintaining mental clarity to potentially delaying neurodegeneration, niacin deserves far more attention in cognitive health strategies. While it is true that most diets provide enough to prevent deficiency diseases, they may not provide enough to sustain optimal NAD production, especially under conditions of chronic stress, poor sleep, alcohol use, or high metabolic demand. Supplementation, even at modest doses, could make a meaningful difference for many individuals, particularly older adults or those with declining cognitive resilience. In the broader picture, niacin represents a clear example of how micronutrients can shape brain performance in quiet but critical ways. It challenges the assumption that age-related cognitive decline is inevitable and suggests instead that with proper nutritional support, the brain may retain more of its sharpness and vitality well into later life. The key is recognizing that mental clarity doesn't just rely on rest or exercise or stimulation. It begins at the cellular level, with molecules like NAD and the humble vitamins like niacin that make them possible.